Welcome back to Applied Mathematics. In this video, we're going to be talking about perimeter and circumference. As you are, I'm sure, already aware, the terminology of perimeter refers to the total distance around a figure that has straight sides. The word circumference refers to the total distance around a figure that has curved sides. And the most frustrating thing in the study of geometry is that we've never invented a word for the total distance around a figure that has some straight sides and some curved sides. But let me get my head out of the way and let's get into some examples here. All right, so jumping in, here we have an irregularly shaped figure that I notice has all right angles. And the fact that it is all right angles means that finding the perimeter is going to be easier than it seems, because there's a lot of sides that are not given to us. Right? We are given this side, this side, this side, and that side. We are not given this side, this side, this side, this side, this side, or that side. Again, the key here is that everything is a right angle. So if we consider just these two vertical sides whose lengths we are given, we don't know what the lengths of these vertical sides are, but we know they have to come out to the same total. So if we take the 5.75 centimeters plus 4.60 centimeters that make up the right side of this in two pieces, and we double it, that will give us the length of the left side, even though we don't know those three pieces. And then we can do the same thing with the top and the bottom. Conveniently, in this particular example, that's also 5.75 and 4.60. But in general, it doesn't have to be. At this point, I turn to my calculator, I crunch all of the numbers, and I get 41.40 centimeters. I am adding all of these measurements together. Yeah, I'm multiplying by 2, but 2 is an exact value here. I don't have to worry about it. I'm adding a bunch of measurements together. All of my measurements are taken to the nearest hundredth of a centimeter, so my result is also taken to the nearest hundredth of a centimeter. How about a circle? Given the radius of a circle, the circumference we know by the formula C equals 2 pi r. My interesting question to you, what if I have part of a circle? What if I only want to measure the circumference of that much of a circle? Well, it turns out that the geometry is actually very forgiving for us here. If I know this angle, let's say I know that that angle is 120 degrees. Well, then that means that the rest of it is 240 degrees because the entire circle is 360 degrees. And if I divide the angle that's inside the circle by the entire angle around the circle, well, in this case, I get 2/3. So the length of the part that's in blue is 2/3 of 2 pi r. I just realized that I got this far, never writing down the radius of the circle. So let's write down that the radius of this circle was 8.5 inches. So my length here is 2/3 times 2 pi times 8.5 inches. And my calculator is happy to tell me that that comes out at about 36 inches. And that can be very useful to us in trying to find the total distance around a shape that mixes straight sides and curved sides. So for example, if I try to draw this shape, and I say try to draw this shape because I'm really terrible at drawing this shape apparently. Here I have a shape where I've drawn in internally a bunch of right angles, and I'm going to mark that the straight sides here are also at right angles. So I have a bunch of right angles and a couple of things that are very clearly not right angles. And let's also go ahead and be nice and say that I know all of these straight lengths as 3.50 inches. There are two sides of this figure that are not given to me that I need to figure out. I have an arc in blue, and I have a diagonal line that I've marked in red. The arc I can figure out using what I just said about circumference. That's a right angle that's marked inside there, which means that that arc is 1/4 of a circle. The radius of the circle is going to be the length of this bit, and since I have a square sitting right next to that bit, that length is the same as this length, 3.50 inches. So plug all of that into my calculator, and my calculator tells me that this length is, looks like it's going to come out at 5.50, 5.4977, but round to 3 significant digits, and that's going to be in inches. The side over here is a little bit harder to see at first glance, but once you see it, hopefully it will make perfect sense. If I draw in, going all the way into the center, that's the hypotenuse of a right triangle. So I can figure that out using the Pythagorean theorem. C squared is equal to a squared plus b squared. Which gives me that c squared is 24.5, and then c itself is going to be the square root of 24.5, which is 4.95. With those measurements taken care of, the total distance around, I'm going to call it P for perimeter, even though perimeter is not the right thing. Well, I've got 4 of the 3.50 inch sides. I've got the 4.95 inch side, and I've got the 5.50 inch curve. My calculator is quite happy to tell me when I punch all of that in that the perimeter here is going to be 24.45 inches. All right. So I know I kind of dove right in off the deep end on these examples. I hope that this is all relatively straightforward. You may or may not have tried to solve a problem that is this complicated in a previous mathematics course, but you have certainly seen the idea of perimeter before and circumference before, so these shouldn't be new ideas, and it shouldn't be that much of a stretch to be able to get here. Relatively short video, but I think it's pretty powerful, so I'll wrap up with that. As always, thank you for joining me, and I'll see you next time.